Okay, this week I want to share with you about the jet stream and how that relates to temperature, since that's what we're studying. This is a look at the 300 millibar map. That is up at about 30,000 feet. Meteorologists don't just look at the air as one layer above them, but many different layers. Remember, we talked about that last week. Okay, so this is up at about where the airplanes are flying, and you'll hear at night the meteorologists talk about the jet stream. It's the area of strongest winds that actually drive storm systems. And you'll see that generally the winds, these are wind bars here, and they point the direction the wind has come from. So this wind is coming from the northwest and going towards the southeast. Okay, so our winds generally run from the west to the east in the mid latitudes. And where you see the blue, that is the higher speed. So this is the strongest wind in here. So this would be the jet stream. Now, what I want you to notice is that you've kind of got a wave pattern. We've got troughs here and ridges here. And just like, think of the ocean waves, and you have really big dips, and then the surf will get really high next to it, or sometimes it kind of evens out. Same thing happens in the atmosphere. And what that is related to is our temperature. So where we have big dips, and we don't really have big dips usually in the summertime, so we've got kind of little ripples moving through. Where you have big dips, you're going to get cooler air. And where you have these ridges, you're going to see warmer air. So now I'm going to look at, this is the 850 millibar map, which will show us the temperature. So just pay attention. Let me lock it in here, to this area of warm air. And what you're going to see is that as that low pressure comes in, ahead of it, the warm air will move up. And then as the low moves through, it'll kind of push this back down as cooler air moves in. So let's take a look through that. As you can see the warm air comes up, gets knocked down. Part of this is due to daytime heating and cooling. But you can see that here we have, let's see if I can mark that in there. There's the low right here. And ahead of it, you've got that warm air. And we're going to talk about fronts in a little while. We have a cold front coming through here. So warm air ahead of the front, cooler air behind that front. And so you're going to see this warm air building up, coming from the southwest. The winds will be coming from the south-southwest ahead of the front, and then cooler air at the north, coming from the north behind it. So when you're watching and learning about these concepts of lows and highs, kind of think of them like waves. We talk of them as waves in the atmosphere. The atmosphere behaves like a fluid. It is a gas. And so we see the same properties of heat exchange, which are convective currents. The molecules actually move and take the warm molecules one direction, cooler molecules another direction. That's why we have the wind. We have that exchange of the air, as the warm air is less dense and the cool air is more dense. And so as the warm air rises, the cool air will come in to replace it. And that's where we get our winds from. So this is another tool for those of you who are in emergency management or those who want to forecast the weather. This is a great tool for you. It's called justin.wiscwx.com. And what you can do here is it's got a bunch of different models that you can look at. This one is the North American model. The one we were looking at was the GFS, but you just decide what level you want to look at. So if I want to look at the surface, I'd add that loop, and then I can take a look at the surface map. We look at the different levels because each level is more indicative of a certain type of weather. So for instance, you look at the 700 millibar because it will, there it is. The green shows you mid-level moisture, and it's kind of an indicator if you've got enough moisture, enough of a moisture source to produce rainfall. One thing while we're looking here, we have a hurricane off here. I remember what the name of it is, Hilda, I believe. And so just skirts along at the bottom of the model. You see it moves up towards the northwest, which is not real good because it's moving into cooler waters. And so you can see that it dissipates within, looks like 96 hours. So there's some tools for you to look at, and hopefully you can join us on Wednesday night. I can go over more of this or any other questions that you have then.